Hello everyone. In today's video, we will be solving a problem based on elastic constant. So here, this is the question. A round bar is subjected to a tensile stress of 85 Newton per mm square and strain induced in the material of the bar is 0.0003. Find the modulus of elasticity. Here, Here, this stress is given in the question and it is denoted by the term sigma. Sigma is the stress is equal to 85 Newton per mm square. And strain induced in the material, strain is denoted by the term small e. And it's given that strain induced in the material of the bar is 0.0003. So stress and strain is given in the question. So here what we need to find is modulus of elasticity. Another name of modulus of elasticity is Young's modulus and it is denoted by the term capital E. So we know that the modulus of elasticity is equal to stress upon strain. So this stress is given in the question as well as strain value is given in the question. So just simply we need to put this value in this equation so that we can get the value of modulus of elasticity, that is 2.8 into 10 to the power 5 Newton per mm square. So this is the answer. This is the answer for the modulus of elasticity, and this elasticity is denoted by the term capital E. Now, the next question is this one. Here, it says that the following data relate to a bar subjected to a tensile test. Is the diameter of the bar D is equal to 30 mm and tensile load P is equal to 54 kilonewton and gauge length, that is denoted by the term capital L, is equal to 300 mm and extension of the bar delta L is equal to 0.112 mm and change in diameter delta D is equal to 0.00366 mm. So we need to calculate here the Poisson's ratio and the values of three moduli. So three moduli is the elastic constant, and elastic constant is the E is the Young's modulus, and G is the shear modulus, and K is the bulk modulus. So in this question, it says that we need to calculate the Poisson's ratio and the elastic constant, that is E, G, and K. So here in the question, it's given that a bar subjected to a tensile test. So this is the bar which is subjected to a tensile force, that is denoted by the term P. So here it's given the diameter of the bar D is 30 mm. So this is the diameter of the bar which is 30 mm. And this load which is acting here is 54 kilonewton and gauge length L. So this L value is the length of this bar is 300 mm. So here the extension of the bar delta L. So here it means that when this force is applied here and it's a tensile force, so this bar will get stretched or this bar will get extended. So after extended, what the extended this was the original length of the bar, and when we pull this bar, then it will get extended. So this extended length is the extension of the bar, that is delta L is 0.112 mm. And the change in the diameter, that means when it will get extended, this length will get extended automatically. What will happen, before the diameter of the bar was 30 mm, so after extension this bar will get reduced. So that reduced diameter of this bar is 0.00366 mm. So now we have to calculate the Poisson's ratio first. So we know that the Poisson's ratio, and Poisson's ratio is denoted by the term mu, is equal to lateral strain upon linear strain. So first we need to find the linear strain here. Okay, so linear strain is nothing but the delta L upon L. Delta L is the change in length upon L is the original length. And we know the value for delta L, that is 0.112. Here it's given, and the original length of the bar was 300 mm. So just putting these values here will get the value for linear strain, that is 3.74 into 10 to the power minus 4. Now this value is known to us. Now next is to find the value for lateral strain. Here lateral strain is equal to delta D by D. Delta D is the change in diameter upon the D is the original diameter. So this is also known to us, delta D is equal to 0.00366 mm, and D, the original diameter, was 330 mm. So we will get this value, that is 1.22 into 10 to the power minus 4. So now we have a value for linear strain as well as lateral strain here. So we can directly put these values in this formula. In mu is equal to 1.22 into 10 to the power 4 upon 3.74 into 10 to the power minus 4. So the answer we got is 0.327. That means the value for Poisson's ratio, and which is denoted by the term mu, or it can also be denoted by the term 1 by m, is equal to 0.327. Now in the question it says that we need to find the Poisson's ratio and the values of three moduli. So this Poisson's ratio has been solved here. So this is the value for the Poisson's ratio. Next is to find the three moduli, that is E, G and K value here. So here now the values of three moduli E, G and K. So E is nothing but the Young's modulus, and we know the formula for Young's modulus, that is stress upon strain. So now strain, we have the value for strain with us, that was delta L by L. So here we need to find the value for stress. So stress formula is nothing but P by A. P is nothing but the load applied on that particular bar, and A is the cross-sectional area of the bar. And cross-sectional area of the bar can be determined by this formula, that is pi by 4 into D square. D square is nothing but the value of D was 30. So P value is the load acting on that bar, was already given in the question, that is 54 into 10 to the power 3. So after putting these values here in this formula, we will get the value for stress, that is 76.39 Newton per mm square. So now the value of stress as well as strain is known to us. Just simply we need to put these values here so that we can get the value for E is equal to 2.05 into 10 to the power 5 Newton per mm square. So now next is to find the value for modulus of rigidity, and this modulus of rigidity is also known as shear modulus, and it is denoted by the term G. So the formula of finding the G value is E upon 2 1 plus mu. So now here we know all the formulas, all the values here. E value we know, mu, that is Poisson's ratio. The value of Poisson's ratio is also known to us. So just simply we need to put the values here so that we can get the value for G. So the value is 0.77 into 10 to the power 5 Newton per mm square. So this value is for the modulus of rigidity. Now the last one is to find the value of K. K is nothing but the bulk modulus, and the formula for finding the bulk modulus is E upon 3 1 minus 2 mu. So we have all the values with us. So just we simply need to put the values here in this equation so that we can get the value for K, that is 1.97 into 10 to the power 5 Newton per mm square. Thank you.